Hello, good morning, students. We are today dealing with the engine performance. So, you want to go for the engine performance and to study in engine performance. We need to study the testing of IC engine. That when we want to study testing of IC engines, we need to know what we mean by indicated power, what we mean by the brake power, what we mean by the frictional power, mechanical efficiency, thermal efficiency, BSFC, heat balance sheet. These are the components of engine performance. Indicated power, brake power, frictional power, all this. Then we should also know the basic parameters. Basic parameters before we proceed ahead. We should know the basic parameters that I'm focusing over here. We should know what we mean by the cylinder bore. The nominal inner diameter of the cylinder is the small d, that is the cylinder bore, it is called as bore. Then a piston area, so area of the circle whose diameter in the cylinder bore, it is the area of the circle whose diameter in the is the cylinder bore, is the piston area. Then a stroke, that is the distance traveled by piston between the two successive reversals, that is the dead centers. I'm talking out only the reversals over here. So it is actually dead centers. So what is the dead center position of piston when it reverses its motion? So what is the top dead center? The top dead center position piston that is farthest away from the crankshaft is a TDC. And the bottom dead center with the position of piston that is nearest to the crankshaft. Then is the piston displacement volume or the swept volume. It is called as generally piston displacement. Just remember, not only displacement is a piston displacement volume. Piston displacement volume. Just note down this. So generally, instead of the swept volume, I write this as piston displacement volume VP. That is pi by 4 into d square into L. This is the piston displacement volume VP. So some authors write at Vs, but I generally prefer it as VP. Just remember. Next is the next important parameter over here is the engine capacity. Is the engine capacity. If you have got one single cylinder, okay, that is the cubic capacity. But if you have got number of cylinders, generally for all the cylinders, generally all the cylinders, we have got the when you have got number of cylinders, I have got 3 cylinders, 4 cylinders, we have to add the displacement volume. Displacement volume means I'm just telling you, it is the piston displacement. It is a piston displacement volume of all the cylinders. If I am adding over that, that becomes the VP, the piston displacement volume. Piston displacement volume. If I'm adding piston displacement volume first cylinder, then VP of 2 plus VP of piston displacement of 3 plus 4 cylinders VP of 4. So all this becomes, this is the engine capacity CE. This is the engine capacity, you should know, that is the engine capacity. Then the clearance volume. So you see, it is a nominal value of the combustion chamber when the piston is at a top dead center. So you know the positions. You know, if you have got this one, this as the cylinder. If I have got this as a cylinder, then if I have got this as a piston, this as a piston. So if I say that the piston is at the top dead center. If I suppose this is the top dead center. Piston is at top dead center. This volume this volume is called as VC. This called volume is called as VC. And the VP, you know, that is the here, just I have mentioned over here. Now we go for the next one, that is a compression ratio. So we understand, we have understood the clearance volume. So clearance volume, the volume of combustion chamber, the piston is at a top dead center. You can see a piston over here. So this, when the piston is at the top dead center, this is the top dead center. So this is actually the volume of the combustion chamber when the piston is at top dead center. This is called as VC. And the we know actually in the earlier slide I have shown you the piston displacement volume. Piston displacement volume. So this again I just can come for that one, the piston displacement volume, so that we can again learn that one over here. I already told you the piston displacement volume. The piston displacement volume is the volume swept by the piston as it moves from the top dead center to the bottom dead center. Okay, so this should be known to you. That is why I'm just showing you again and again. These are the basics. These are the basics you should know. So piston displacement volume, and next is the clearance volume. So next comes the compression ratio. So what is the compression ratio? So compression ratio is the ratio of the cylinder volume at bottom dead center to the clearance volume. So at the bottom dead center we have got uh, clearance volume plus piston displacement volume Vp. So Vp by Vc, again I write here Vp by Vc. So this compression ratio, just I am telling you, for the spark ignition engine, that is petrol engines, if I believe the petrol engines it is 6 to 10, whereas for the compression ignition engine it is 12 to 20. Compression ignition engines means diesel. Is it clear? Is it clear now? The compression ratio, the piston displacement volume, the clearance volume. Say you get confused over here. What is compression ratio? So number of times when I ask what is compression ratio, you will tell me, sir, it is delivery pressure by the suction pressure. The ratio of delivery. It is not like that. It is the ratio of the cylinder volume in the piston is at VDC to the cylinder volume in the piston to the piston is at TDC. Okay. So when it is TDC means it is a clearance volume. Again, let you know these things. Huh? Clearance volume. So the volume of the combustion chamber with the piston is at TDC. So these are the compression ratio, the uh, ratio of the volumes actually when the piston is at VDC and when the piston is at TDC. Just remember this. So this is VC plus VP by VC, and 1 plus VP by VC is the compression ratio. Okay, is it clear? So anybody can tell me, is it clear now? Compression ratio, am I audible to you?
Yes, sir.
Okay, so the objectives of testing an IC engine is that, see, we want, see, I'm just telling that my engine is delivering 5 kilowatt, 5 kilowatt. So how as a purchaser I will know that this engine is of 5 kilowatt. So that has to be tested. So therefore testing has to be done to satisfy the customer. Testing has to be done for, see, we are testing the engine because we are going for R&D, research and development, which are we are going for research and development. Unless and until the engine is being run at various loads, no doubt you have designed the engine, but the actual testing, when you are actual testing, what is happening? So so the testing gives you a clear cut information how the engine is working, whether it's smooth working or not working. So so therefore the engine testing is done. So what are the performance parameters? So when I'm just telling we want to just study that is going for testing of engines, so there are certain performance parameters. So very first parameter is the, you can see over here, is the brake power. Is the brake power. So what is the brake power? It is the power available at the output shaft, that is crankshaft. So you have, I know that you have got an engine, and at the engine at the output shaft, whatever power that is available, that is called as brake power. Then there happens to be various losses, frictional losses, pumping losses. So these friction losses, pumping losses, they are called as frictional power. Then what is the indicated power? IP. So it is a theoretical power. It is a power produced inside the cylinder, that is called as indicated power. So indicated power, the very first formula you should note here is the indicated power is equal to brake power plus frictional power. So what, see, you have got an engine. So engine is developing the power. Engine is developing the power. Engine is developing the power. So this power Engine power, I'm just telling you, this engine power, that is the power which is developed inside the cylinder, is called indicated power, and that is brake power plus frictional power. So tests are performed on the IC engines to find out the indicated power, the brake power, the frictional power, the mechanical efficiency, to calculate the air-fuel ratio, to find out the BSFC, to calculate the thermal efficiency, and working out the heat balance sheet, how the heat is coming out, how the heat, when you are burning the fuel, heat is coming out. So QS, this is mass of the fuel multiplied by the calorific value. So this is generally, this is in kg per second. Kg per second you get in, here you get in kilowatts. You get in kilowatts. So this is the heat. When I say the heat balance sheet, one part, the first part is what is the heat supplied, heat supplied, and then this heat is being utilized. This is being utilized for the power. So QBP. So QBP will be BP, the brake power that is being developed. Then the engine coolant has got coolant, or we say water, which takes out the heat. So the QW has to be found out. Then you have got exhaust gases which are taking the heat. So QG. And then you have got the Q unaccounted, Q unaccounted in the heat balance sheet, and so this unaccounted takes other losses other than the brake power, the heat carried by the water, heat carried by the gases. Okay, by the gases. Okay, I think you must have understood this. The heat balance sheet. So it shows how the heat is coming and how heat is going out by this way. So this is the engine mechanical indicator. I have already told you that we want our basic aim when are testing to find out the indicated power. So indicated power is the power which is developed inside the cylinder. Inside the cylinder. So inside the cylinder, since we want to find out the power inside the cylinder, so generally there happens to be the mechanical indicator. So generally, it is a cylinder a cylinder which is called as the drum, over which the paper is being wound up. Paper is being wound up, and there is a stylus. There is a stylus. This stylus is being given a horizontal and vertical movement. Two movements are there, and when the total cycle is being made, that is, if you have got a four stroke, there will be suction stroke, there will be compression stroke, then there will be the power stroke, then there will be expansion stroke. And I already told you that. So you get when I am just that is getting the indicated power, I will be getting the indicated power in this format. You can see the indicated power, that is the uh, this is the indicated power. This is PV diagram. Actually, this is PV diagram. You get the indicated, you get the indicated power with the help of the mechanical indicator. Okay, so so indicated power is determined by the indicator diagram. So indicator diagram is obtained from the this I already told you, the engine mechanical indicator. This is an apparatus for use for drawing the actual PV diagram. Then drawing the actual PV diagram, actually I have drawn the PV diagram over here. I have told you I get, when the stylus is being connected, I get in this format. So if this format what I get, so this is the indicated power. So this area is whatever this area is, this area is actually is the giving you what is the indicator power. This part, see this, again I'm just drawing in detail this one. So you have got this part, and you have got like this part. So these two part, this part is positive and this part is negative. This part is negative. So you can see the positive part and negative part. So this plus and this minus. So when you are adding that, these two, you get the total indicated power. So generally, the indicated power is being obtained by using the mechanical indicator, and vertical movement of the stylus and the horizontal movement of the cord combines to produce the closed figure that is called as indicator diagram. And the area, see, you are not getting the some rectangle, you are not getting a triangle over here, but you are getting irregular shape. So when this irregular shape you are getting, this irregular shape is measured, the area of this is measured by plane. Area is measured by plane. So if you have got, if you are measuring the area, this is the A, this is the A, this is the length of the diagram, this is L. I have already told you. So what you are getting on the indicator diagram, the indicator diagram, this is the positive work and this is the negative work. What you are getting, positive work and negative work are getting. So initially, you have got a suction stroke which is obtained. That is, this suction stroke is carried up below atmospheric pressure. Then you have got a compression. So this you can see compression. Then at this part there is ignition. So there is an increase in pressure. Thereafter you have got the expansion stroke, and then you are opening the exhaust point or exhaust valve over here, and therefore you have got an exhaust stroke which is carried above the atmosphere. So this you should remember. This you should remember to understand how the indicator diagram is drawn. So when we are getting the indicator diagram, we just find out the PMI. So if we are measuring the area, this area, so this is the positive loop and this is the negative loop. This is the negative loop. So this area A, this is AP minus AN. Just remember this thing. This area is, this is the positive one and this is the negative one. So positive minus negative, you get this area. This length of the indicator diagram is L, and K is the stiffness of the spring stiffness. K is the spring stiffness. So the spring which is provided at the stylus, for that the spring stiffness is K. So the formula for the PMI, what we want is A by L into K, is the PMI. So you may wonder why we go for the PMI. So PMI, so PM, when I get PMI, that means I am getting the pressure. When I am getting the pressure inside the cylinder. If I know the area of the piston, so PMI into A, area of the piston, I will get pressure multiplied by area. I will get the force on the piston. And if I want to find work done per cycle, it is PM area into L. And if I want, that is for revolutions per minute, revolutions per, see, for this is for the single revolution. This is for the single revolution. Single revolution. If I have got number of revolutions, so that is given by small n. And this small n, again I am telling you that this is n, small n. Small n is n for the two stroke, for the two stroke, and this small n is n by 2 for the four stroke. This has to be remembered. यानी अगर ये टू स्ट्रोक इंजन है तो एन एन रहेगा, कैपिटल एन. अगर मेरा 4000 आरपीएम है तो ये 4000 आरपीएम रहेगा, दिस एन. अगर ये जो हमारा है फोर स्ट्रोक इंजन है तो हम क्या करूंगा, दिस 4000 डिवाइडेड बाय 2, 4000 divided by 2 means this becomes, this n becomes 2000 for the four stroke engine, while it is 2 for the two stroke, it is 4000. And it has to be number of multiplied by number of cylinders. This is for single cylinder. ये जो है ये सिंगल सिलेंडर के लिए, और ये है जैसे पर सिलेंडर. इफ यू एन नंबर ऑफ सिलेंडर, दो है तो दो लिखेंगे, तीन है तो तीन लिखेंगे, चार है तो चार लिखेंगे. सो द बेसिक फार्मूला, just you can that is know the basic formula here for the indicated power is IP, that is PMI L A N divided by 60 into 1000. So divided by 60 means, since we have got this an RPM, so to get in seconds it has to be divided by 60, and this for the watt we want in kilowatt, we want in kilowatt, and this should be multiplied by number of cylinders. So this is for this is for a single cylinder, ये सिंगल सिलेंडर के लिए. और नंबर ऑफ सिलेंडर्स मुझे ऐड करने का है तो इनटू, एक है, दो है, तीन है, चार है, so that is to be NOC. So I think you must have understood the IP. So IP, again I am just writing the formula for the IP. If I want to find IP, I should write IP is equal to PMI L A N divided by 60 into 1000. So into NOC, that is number of cylinders, so I get in kilowatts. So this I am writing 1000 to get in kilowatt. I am writing 60 because this n is in RPM. ये RPM में है, मुझे किस में चाहिए, RPS में चाहिए. If I want to go get in RPS, I have to divide by 60. Did you understand this? Integrated power. So shortly IP is called as, हमको अगर याद रखने का है इसको तो हम सीधा बोलते हैं IP is plan. हम सीधा बोलते हैं इसको plan. We say it is plan. IP is plan. So 60 for the RPM and 1000 for the kilowatts. This you should remember. I will get and multiplied by number of cylinder NOC. So this should be your basic formula. This should be your basic formula. Huh? This should be your basic formula. Okay. So this L is the length of the stroke. This L is the length of the stroke. This P is the PMI. This PMI. L is the length of the stroke. And A is the area of cylinder. Pi by 4 d square. Pi by 4 d square, where d is the diameter of the inner diameter of the cylinder. Inner diameter of the cylinder. Okay. Yes. So we have measured the indicated power. So I just want to measure now the brake power. So how the brake power is measured? So you have got output shaft. At the output shaft, you have got a flywheel. You have got a flywheel. So this is the flywheel. This is a flywheel. You can see in the output shaft. So on the flywheel, you have got a brake drum. So brakes are applied. Brakes are applied over here. So to apply the brakes, what we do is that we generally uh, wind up a rope around the flywheel, and attach weight to it. So here the weight is attached, and other end we attach the spring. So what do we get? So you get your net brake load will be W minus S. This previous, so you are getting W. So W, so your load is going here. Your spring load is here. So it is W minus S. Just I am telling what is the load. Load is W minus S, and the torque is the brake diameter. So generally this brake diameter is the brake, that is brake drum diameter, and rope drum diameter. Just remember. So if I want to find R, this RB, so this RB is D plus D by 2, where the D is the brake drum diameter and this is that is rope diameter. D plus D by 2, and multiplied by y is pi and 60,000. So generally I'm just giving you the example. How if I have to write the brake torque, मुझे अगर ब्रेक पावर निकालने का है, ब्रेक पावर, सिंपल फार्मूला फॉर द ब्रेक पावर इज, आई एम जस्ट टेलिंग यू, दिस इज द बेसिक फार्मूला, twice pi. If you remember this, you will remember everything. Twice pi nt by 60 into 1000. I'm just telling you why 60, because this is in rp, ये rpm में है इसलिए डिवाइड बाय 60. 1000 क्यों? Because I want in kilowatts. So for this, now this becomes twice pi, and so I write 60 into 1000, 60 into 1000 multiplied by, if I want to torque, so torque is W minus S, and it is D plus D divided by 2. D plus D divided by 2. So hope you understood, and you get the this value in kilowatts. You get this value in kilowatts. So hope you have understood the brake power or the brake power. The basic formula of the brake power is twice pi nt by 16 to 1000. That comes into kilo. That is kilowatts. Okay. So this is a pony brake. So there are a number of methods by which load can be applied at the output shaft. So if I am attaching the brake shoes, so this type of brake shoes if I am attaching, अगर मैं ये brake shoes apply करता हूँ यहाँ पे, brake shoes apply करता हूँ, and just I am attaching the load over here. So load is attached at the length L. Load is L attached at the length L. So your torque becomes W into L. W into L. So you can see over here, again over here. So your weight, ये weight है, ये length. So again, just that formula just I told you earlier. If you want to find a brake power, you have to find brake power. for such kind of the that is Plony brake, I'm just writing twice pi nt by 60 into 1000. Why 60 you have got 60 for this is in rpm, इसको rps में करने के इसलिए what is 1000 for making watt into kilowatt. So again here, so brake power is twice pi into n, and what is the torque here? Torque is load into the length w into l and divided by 60 into 1000. Earlier it was W minus S in the rope brake diameter plus, that is into D plus D by 2. Here it is length for the Plony brake, for the Plony brake type of the dynamometer. Then is the we generally go for finding out what is the frictional power. What is the frictional power? So difference between the indicated power and the brake power is the frictional power. So this again, so I have written, I know that this IP is equal to BP plus FP. So therefore FP, if I have to find, is equal to, that is IP minus BP. IP minus BP. Sir, what the frictional power includes? It includes the pumping losses. It includes the frictional losses in bearings. It includes the power required to drive the auxiliaries like governor, water, then lubricating oil, fuel pumps, alternator, valve operating mechanism. So these are the losses actually. These are the losses, and theoretically, FP increases as a square of n. Practically, it is FP is directly proportional to n to the power 1.6. So if we have higher frictional power, that means you will be getting reduced power output, decreased mechanical efficiency, increased BSFC, brake specific fuel consumption increase, and increased the requirement of the cooling. So we want the frictional power to be as less as possible. So what are the different methods of measurement of frictional power? So if you can measure the indicated power and frictional power separately, so you have got indicator card, you measure indicated power. You have got a brake dynamometer, you make it brake power. So what is the frictional power? Then the basic formula is IP is equal to BP plus FP. So if I want to find FP, so FP will become IP minus BP. So simple. If you can measure the indicated power and brake power separately. Next is the Williams lines method. Next is the Williams line method. Let us go for study of finding out the Williams line method. So in the Williams line method, what is the Williams line method? I think it is visible to you. So in the Williams line method, the brake power. So on one that is on x-axis, we are that is plotting the brake power, and the other axis on the other axis you are just that is uh, having, on other axis we are having the fuel flow rating kg per hour. So when you draw this graph we get number of points over here. यहाँ पे एक पॉइंट मिला मुझे, यहाँ पे मुझे एक पॉइंट मिला, यहाँ पे मुझे point. ठीक है, so I get these points. So what do I do next is that I extrapolate, ये जो है points है, I extrapolate means, see I'm getting up to here only, so I extrapolate and just go up to here, go to the, here means go to the negative side of the x-axis, and now whatever I get here, so this whatever I am getting over here, this is the frictional power. This is the frictional power, plus just remember this is the frictional power. This is the frictional power. So what I have got, I have plotted, a graph between the brake power and the fuel flow in kg per hour, and that is extrapolated to cut the negative side of the x-axis at this point, at point number A, if I suppose. So whatever this we are I'm getting over here, this measurement of this is the frictional power. So graph between the fuel consumption, that things again mentioned over, fuel consumption and the BP on the x-axis drawn, and you are running at the same any speed. So that is being extrapolated. So to get zero fuel consumption, which cuts the negative axis at point A. That's already shown to you. यहाँ पे जो मिल रहा है, फिर से मैं इसको निकाल रहा हूँ, इसको हम एक्सट्रापोलेट करते हैं. सी यू आर गेटिंग द पॉइंट. फिर से मैं बता रहा, आपको जो पॉइंट मिल रहा है, आपको जो पॉइंट मिल रही है, वॉट एवर द पॉइंट्स यू आर गेटिंग इज दिस पॉइंट्स, ये आपको पॉइंट मिल रहा है, दिस आर द पॉइंट्स यू हैव गॉट. These are the points you are drawn. And now what you draw is you draw this vertical line over here. That is this line over here. Extrapolate this line so that it cuts here. So this portion, again I am telling this portion, this portion what you are getting over here, ये जो आपको मिल रहा है यहाँ पे जो मिला है आपको. So this is the frictional power. This is the frictional power. So just this is generally used for the CI engine. This is generally used for the CI engine, not for the petrol engines. This again has to be measured. Then there is another method from which the frictional power is measured. Is the so you know that basic we know that IP basic unit IP is equal to BP plus FP. This is the basic equation. If I find FP is IP minus BP. This is well known equation. अगर इंडिकेटेड पावर हमको पता है, हमको ब्रेक पावर अगर पता है हमको, तो फ्रिक्शनल पावर हमको पता हो जाएगा. So with this basic formula, a Morse test has been done. So generally this is Morse test is used for the SI engine and the CI engines. इसमें हम क्या करते हैं, इसमें हम क्या करते हैं? So what we do here in the Morse test. So in the Morse test, generally they are carried. You should know that they are carried generally if you have got the cylinders, 3 cylinder or more cylinders, we are carrying the more space. We are cutting off each cylinder in turn. Cutting the cylinder means what we are doing? We are making the sparks plug of the first cylinder, the second cylinder, the third cylinder. Now, depending on the number of cylinders, we are making them as inoperative, one by one. Or if it is CI engine, we are cutting the fuel supply. If is a we are cutting the fuel supply, we are cutting the fuel supply. ठीक है? We are cutting the fuel supply, that should be known to you. This is the more steps we are cutting one by one, and then we are measuring the. So when when we are cutting that, we are cutting the fuel supply, or we are cutting the spark plug, we are adjusting the load in a just in a way that the three cylinder, if you have got a four cylinder, the three cylinder will be running the first or motoring the first cylinder. So how the that is a more stage is carried out. First we run the engine when all cylinders are working. So this is the brake power when all cylinders are working. Then we run, that is we cut off, may we make inoperative the very first cylinder by cutting off the spark plug. Spark plug हमने पहले सिलेंडर कट ऑफ किए, तो क्या होगा, 3 सिलेंडर रन होंगे, चौथा है पहला सिलेंडर रन रन नहीं होगा, 3 सिलेंडर रन होंगे क्योंकि स्पार्क प्लग चालू. तो ये 3 सिलेंडर क्या करेंगे, ये पहले सिलेंडर को चलाएंगे. दे विल रन द फर्स्ट सिलेंडर, दे विल मोटर द फर्स्ट सिलेंडर, बट यू आर गेटिंग द ब्रेक पावर ऑफ फ्रॉम ओनली 3 सिलेंडर. तो इसको हम B1 बोलते हैं जब पहला कट ऑफ होगा. फिर हम वैसे ही हम क्या करेंगे, दूसरे को कट आउट करेंगे तो ये B2 हो गया. फिर हमने तीसरे को कट आउट किए, फिर भी ब्रेक पावर मिल रहा, ये B3 होगा. फिर वी आर cutting the fourth cylinder, that becomes B4. So when we are adding this B1, B2, B3, when I'm just that is if I want to find out, हमको अगर चाहिए कि मुझे अभी IP1 निकालने का है. सो देखो देखो पहले मैंने क्या किया, ब्रेक पावर ऑफ इंजन व्हेन ऑल सिलेंडर्स वर्किंग, दिस इज B1 मींस पहला सिलेंडर कट किया, तो मुझे इसमें से क्या मिलेगा, मुझे मिलेगा IP1. What I get? IP1. IP1 means B minus B1. Okay. Then I will get IP2. IP2 बोले तो कैसा, B minus B2. IP3 बोले तो कैसा, if I want to find IP3, B minus B3. If I want to find I4, IP4, फोर सिलेंडर B माइनस B4. सो हियर B1 B2 B3, हम जो B1 B2 B3, तो इसमें क्या हो रहा है, मैंने क्या किया हूँ, पहला सिलेंडर कट ऑफ किया, दूसरा सिलेंडर कट ऑफ किया, थर्ड थर्ड सिलेंडर कट ऑफ किया यहाँ पे, और यहाँ पे फोर्थ सिलेंडर. इसका जो ब्रेक पावर है B1 B2 B3. तो मैं क्या कर रहा हूँ, देखो पहले मैंने व्हाट आई हैव डन हैज रन ऑल सिलेंडर, आई हैव गॉट B. सो B माइनस B1 किया तो मुझे IP1 मिला, B माइनस B2 किया तो मुझे IP2 मिला, B माइनस B3 किया तो मुझे IP3 मिला, B माइनस B4 किया तो मुझे IP4 मिला. और ये जब मैं ऐड करता हूँ, मैं जब ऐड करता हूँ IP1 प्लस IP2 प्लस IP3 प्लस IP4, आई गेट IP. सो मुझे IP भी मिला. ये जो ब्रेक पावर तो मैंने पहले ही मेजर किया है. इफ आई फाइंड फ्रिक्शनल पावर, सो फ्रिक्शनल पावर विल बी IP माइनस BP. IP minus BP. So that is how the Morse test is being carried out. So I already told you this one. So we are getting the IP and BP over here. Huh? Okay. So these are the standard efficiencies, you know. These are the standard efficiencies you should know. For the Otto cycle, the efficiency, for the diesel cycle, for the dual cycle. So these are also called as air standard efficiencies. So air standard efficiency 1 minus 1 for Otto cycle, 1 minus 1 upon R to the power gamma minus 1. For the diesel cycle, 1 minus 1 upon R to the power gamma minus 1, rho to the power gamma minus 1, gamma rho minus 1. So rho is the cutoff ratio over here. So now various efficiencies. If I want to find various efficiencies, so first one is the indicated thermal efficiency, IP, indicated thermal efficiency, eta I, IP that is divided by MF into calorific value. ब्रेक थर्मल एफिशिएंसी निकालने का है तो ये ब्रेक पावर डिवाइडेड बाय एमएफ इंटू कैलोरीफिक वैल्यू. नेक्स्ट मैकेनिकल एफिशिएंसी ब्रेक पावर बाय आईपी. रिलेटिव एफिशिएंसी ब्रेक थर्मल एफिशिएंसी और or indicated thermal efficiency divided by air standard efficiency. So depending upon what kind of relative efficiency you want. Regards to brake thermal, तो ब्रेक थर्मल सो रिलेटिव एफिशिएंसी रिगार्ड्स टू ब्रेक थर्मल हो जाएगा, इंडिकेटेड तो इंडिकेटेड हो जाएगा. ओके. Then is the volumetric efficiency. So volumetric efficiency is actually volume of air actually taken in divided by piston displacement volume. So generally I say this is, I say number of times this is piston displacement volume. जैसे पहले बार भी मैंने आपको बताया था piston displacement volume. So I generally write eta V. Eta V is volume of air which is actually taken in by piston displacement volume. Then BSFC, you should know the BSFC. BSFC is the mass of the fuel required to be supplied to the engine, MF divided by the brake power. This MF is in kg per hour. ये MF किस में है? ये MF kg per hour में, kg per hour में निकालना. MF by brake power is the BSFC. Okay. So this is very important. Then regarding the heat balance sheet, I have already told you we need to find the QS. QS is MF into calorific value. Then I have told that heat equivalent to brake power is the BP. BP itself, brake power itself. QBP is brake power itself. Heat which is carried by the cooling water MCP delta T. The heat which is carried by the exhaust gases MCP delta T again. So here we are, that is mass of the exhaust gases, CP of the exhaust gas temperature minus the room temperature, and unaccounted that is heat which is unaccounted is the difference, that is a QBP minus that is a QS minus QBP minus QW minus Q exhaust will be heat unaccounted. Okay.